बस 1 मिनट देना। अच्छा चलो ठीक है, स्टार्ट कर लेते हैं। और अच्छा ना, KSP ठीक है। KSP is known as the solubility product, ठीक है। अच्छा remember वो pH वाला, all of that's over now, ठीक है। So this is solubility product, this is an equilibrium constant, but it's got nothing to do with what you studied previously, ठीक है। pH वगैरह, it's got nothing to do with that. इसमें होगा what is solubility product? It's when something dissolves, ठीक है। When any salt crystal dissolves, it reaches a point which is known as the saturation point or the crystallization point, ठीक है। So for example, if I'm trying to dissolve NaCl, there would come a point when the crystal would stop dissociating, ठीक है। So for example, if there's a crystal, tiny crystal of Na+1 Cl-1, so Cl opposite ions attracting each other. So let's say there's this tiny crystal and the ions are attracting each other. So if you try to dissolve it, the ions will dissociate. So all these ions would randomly dissociate, and they would be randomly moving around, okay? So haphazardly, randomly, they'll be moving around, mixing in water, okay? So they're all randomly moving around. But the dissociation would happen up to a certain point. At a certain point, the crystal would stop dissociating because there would be too many ions already in the solution. And that is when an equilibrium would be established. Okay? So if I try to dissolve NaCl, okay, solid, and I try to dissolve it in water, aqueous. So initially it will dissociate, it will turn into Na+1 aqueous and it will turn into Cl-1 aqueous. But at a certain point, it will reach an equilibrium point. Okay, the more you try to dissolve it, the more you try to dissolve more of the NaCl, the sodium and Cl ions will combine to form the crystals back again. Okay? So it will reach a reversible or equilibrium point. That happens when the solution is saturated. Okay? ये clear सारों को?
Yes.
Yes, sir.
ठीक है, the solution is saturated. So there's no, I mean, it's not going to dissolve anymore. Okay? So, but it will be dissolving. It's just that the reverse would also be happening. So, मतलब यहाँ से sodium ion dissociate होता है, another sodium ion from the solution would take its place. ठीक है? So in effect, overall, nothing would happen. अच्छा, now KSP, the equilibrium constant, is specifically for a solution that's already reached saturated point. ठीक है? If it's not saturated, KSP does not apply. ठीक है? So remember this is only for, it's only for saturated solutions. A simple concept, right? Concept is that since it's clearly an equilibrium reaction, so it's going to have an equilibrium constant. That equilibrium constant is going to be called KSP. So it's going to be product concentration divided by reactant concentration. The products are sodium ions and Cl ions, aqueous state. So it's going to be the concentration of those ions and divided by the reactant concentration. The reactant right now is NaCl solid. So it's NaCl solid. Or solids का मैंने पहले बताया था, it's solids solids are taken as a constant concentration, so you take it as 1, or you combine it with this equilibrium constant. You don't write solids in your expression because their concentration does not change. Okay, ये clear है?
Yes.
अच्छा, तो उससे आगे ये किधर गया? So that's it. So basically, KSP is just going to be your product of the ions in the solution. That's it. Okay? It's going to be whatever the ions that are produced. Because your reactant hoga, that's going to be a solid. The salt will be a solid and it's dissolving. So it's just going to be a product of the ions. So that's your KSP expression. You'll be asked to figure out the units. So it's concentration times concentration. So kya hoga? Mole per dm cube squared. So mole squared dm minus 6. Okay? That's going to be its unit. Okay? If you have a different salt, and KSP would have a large value. When would it have a large value? If the substance is very soluble. So KSP indicates how soluble the salt or whatever you're dissolving is. So KSP will have a large value if more dissociated ions are produced, if substance is very soluble. ठीक है, ये भी clear है?
Yes, sir.
Yes, sir.
Achha, so let's do another equation. Okay, what's the KSP value for that reaction? So let's say there's a salt, aluminium sulfate, ठीक है? And this salt solid will dissolve. ठीक है? It will dissolve in an aqueous solution. And when it dissolves, it's going to produce what? It's going to produce Al3 plus aqueous ions, and it will produce SO4 minus 2 aqueous ions. So वो जो salt है ना, it's going to dissociate, and it's going to produce 2 aluminum ions and 3 sulfate ions. ठीक है? तो ions जो है ना, they're going to be produced, and they would dissociate. And so you're supposed to write the KSP expression for this. The KSP expression would be product concentration, which in this case would be aluminum ion concentration. That's going to be squared, or SO4 minus 2 concentration, and that's going to be cubed. वो जो coefficient होता है ना, that becomes the power. And obviously you don't write the reactant concentration because that's going to be a solid and it's taken as 1. ठीक है? तो ये आपका KSP का expression है, and you just have to, the unit for this is going to be concentration squared into concentration cubed. तो वो mole 5 dm minus 15 हो जाएगा. The concentration, if I take concentration as x squared, x cubed, so that's x to the power 5. Okay? So it's concentration, sorry, minus 15. अच्छा अभी तक 1 सेकंड रुको, हैंग हो गया. So मेरे बोर्ड पे ना डेटा बहुत ज्यादा हो गया, so it just keeps hanging up. दोबारा ही लिख लेते हैं. अच्छा, so it's going to be mole 5 and your DM is going to be minus 15. ठीक है? So is this clear? ये वाला.
Yes.
Achha, now you're going to get 2 types of questions on that. One is that you'll be asked to figure out the unit or the expression. The second one is you'll be asked to figure out or calculate the value of KSP. Okay? Now, most of the time they'll give you solubility. They'll say something like this. So there's an example question which is, achha, so example question is, they'll say that the solubility of a certain salt. So let's say solubility of MgCl2 is, achha, solubility could be in gram per dm cube or it could be in mole per dm cube. So let's say gram per dm cube. So he says that it's 0.15 gram per dm cube in a saturated solution. अच्छा, in a saturated, एक सेकंड यार, मैं स्टार्ट ही कर लूं दोबारा. अच्छा, यहाँ पे था solubility of MgCl2 is 0.15 mole per gram per dm cube. In अच्छा, in a saturated solution. अब ये दिया हुआ है. So that means, when they talk about solubility, that means this is the amount that is dissolving. So MgCl2 will dissolve and it will produce what? It will produce Mg2 plus ions and it will produce 2Cl minus 1 ions. ये दो ions produce होंगे in an aqueous solution. So I need to figure out what is 0.15 gram per dm cube. How do I convert that into mole per dm cube? So I'm going to do that. So how do you convert grams to moles? Moles में convert करना, you just multiply mass divided by mR, right? So 0.15 grams per dm cube divided by the mR of MgCl2, which is Mg कितना है 24.3 plus 2 Cls, that's 71. Can somebody quickly tell me how many mole per dm cube is this? क्या आ रहा है?
(1.57 times 10 power minus 3).
So it's 1.57 times 10 to the power minus 3 mole per dm cube. But वो grams को moles में convert कर दिए. So that's the amount of salt that is dissolving. So that means 1.57 times 10 to the power minus 3 mole per dm cube. Moles per dm cube dissolves. So how much Mg ions will be produced? Mg ions will be exactly, it's 1:1, so it's going to be 1.57 times 10 to the power minus 3 mole per dm cube. Achha, solubility is the thing that has dissolved, okay? When somebody mentions solubility, that's the amount of salt that is already dissolved, okay? So Mg ions will be exactly the same. Cl ions kya honge? Wo double honge, okay? According to the ratio, that's going to be, what's double of this? That's going to be 3.14.
3.15.
That's a 3.15. So it's going to be 3.15. That's a 3.15 times 10 power minus 3 mole per dm cube. Okay, so remember what solubility means. Solubility means that this is the amount of salt that has already dissolved. So you've got these ions in solution. So अब आपने क्या करना है? खाली you just have to write the expression for. अच्छा, you just have to write the expression. एक सेकंड में बैटरी. Sorry. अच्छा, अब ये वाला है कि the KSP expression for this is Mg ion concentration times Cl minus 1 concentration, and that's squared. So it's going to be 1.57 times 10 power minus 3 multiplied by 3.15 times 10 power minus 3, and that's going to be squared. So what value do you get?
So 1.56 times 10 power negative 8.
कितना negative कितना?
Negative 8.
-8 and the unit is going to be concentration times concentration squared, तो वो cube हो जाएगा, ठीक है? So it's going to be concentration mole 3 dm minus 9. ठीक है? So all you need to understand is that solubility is the amount of salt that is dissolved. So if it's 0.15 gram per converted into mole per dm cube, so this is the amount that is dissolved. This is the amount of ions that are going to be produced. And using those concentrations, you can just plug it in the expression and you'll find the value of KSP, ठीक है? तो ये clear है?
Yes, sir.
अच्छा, अब जो next चीज है, ठीक है? The next thing is कि we've got the second type of question. अच्छा, KSP for salts, I mean, KSP is a value that only changes with temperature. ठीक है? Like any equilibrium constant, ये भी यहाँ पे लिख दूं, KSP is something that's always a constant. And only one thing changes it, and that's temperature. All equilibrium constants, they change with temperature. So KSP only changes with temperature. And I think most salts, they become more soluble when temperature increases, but that's not necessarily true. Some salts dissolving is endothermic. So in that case, when temperature increases, they become, endothermic becomes more soluble. If enthalpy of solution is exothermic, then they become less soluble, ठीक है? So it depends करता है, what is the amount of energy that's being released or absorbed, ठीक है? Exothermic things happen at lower temperatures, endothermic things, they prefer higher temperatures. So, but anyways, so that's example number 1. Example number 2, that's the reverse, ठीक है? As remember, this is a made up value. अगर मैं Google करूँ ना, like this is just made up data, right? The KSP is coming out to be this. So, अगर मैं Google करूँ ना, you'll get the value of KSP. Just 1 second. Of different salts. 1 second. तो ये मेरे ख्याल से ना, हाँ, KSP of some popular salts. अब ये देखो ना, if you look at aluminum hydroxide, it's not, and remember it's calculated at 25 room temperature, ठीक है? So that's like standard KSP. The aluminum hydroxide is not very soluble, so that means it's got a very, very small KSP value, because the amount of ions that are going to be produced are going to be very tiny, ठीक है? Aluminum, this is also insoluble, 10 power. This kind of looks very soluble because it's quite high. That means a lot of ions are being produced. So things that are insoluble will have extremely low KSP values because they would have very few ions. अच्छा, अब तो यहाँ पे I just want to show you something that's very soluble. I think sodium salts, right? तो Na देख लेते हैं. Sodium salts are like very soluble. HIJKLMN, 1 second. T आ गया. Na. अच्छा, Na के लिए calculate ही है because they're so soluble, ठीक है? I guess lithium salts, group 1 salts, kind of soluble, ठीक है? So they've got a low KSP, ठीक है? Silver salts are very insoluble, ठीक है? Silver chloride कहीं है, AgI is like very insoluble, so it's got a low KSP, ठीक है? So anyways, all these KSP values are calculated, ठीक है? So just moving on. Reverse question, ठीक है? The opposite question. The opposite question is second example. अच्छा, पहला example था you calculate KSP value. So you're calculating KSP. The second example is KSP is known. So what you have to do is you have to find equilibrium, or you have to find the opposite. You have to find the solubility. You have to find the concentration of the salt. So either table say I'm going to pick a KSP value. Let's say, वो aluminum hydroxide pick कर लेते हैं. Aluminium hydroxide was what? 3 times 10 to the power minus 34. So I'm going to try and find out what is the concentration of aluminium hydroxide in this solution. This is the Ksp value. I'm going to try and figure out the concentration. So kitna 3 into 10 to the power minus 34. So Ksp of aluminium hydroxide is 3 times 10 to the power minus 34. Iska jo unit hoga na, that's probably going to be mole 4 DM minus 12. That's your Ksp. So isko reverse mein kaisa karenge? You're going to do exactly the same thing. Aluminium hydroxide dissolves. So it produces 2 ions. One is Al3 plus. The other one is OH ions, 3 OH ions, aqueous. Now, I don't know how much aluminium hydroxide dissolves. I have no idea how much aluminium hydroxide is dissolving in a saturated solution. So I'm going to take it as X mole per dm cube. मुझे नहीं पता कि how much dissolves, ठीक है? So X mole per dm cube. So the amount of aluminium ions in a saturated solution would be X mole per. And the amount of OH ions, that's going to be so that's going to be 3x mole per dm cube. Clear? 3 OH ions ban rahe. Is that clear?
Yes, sir.
Yes, sir.
What is the Ksp expression? The Ksp expression is aluminium ion concentration multiplied by OH ion concentration, and that's going to be cubed. Okay, product over reactant. Reactant solid is, so you don't write it. Now, you know the aluminium ion concentration, that's X. And you also know the OH ion concentration, that's 3X. So it's X times 3X cubed. And you know the value, the value is already known, that's 3 times 10 to the power minus 34. उसने Ksp तो पहले ही दिया हुआ था, 3 times 10 to the power minus 34, right? So you're going to solve for X. It's going to come out to be 3 cube क्या होता, that's 27. 27, right? 27 ही होता, 27. X4 is basically equal to 3 times 10 to the power minus 34. Now you got to solve this. So it's going to be what X4 is 3 over 27 times 10 to the power minus 34. So 4 hatao, so that's going to be, I mean, you have to calculator pe kissa karte hain, try and do this, okay? What do you get?
So 1.83 times 10 power negative 9.
Get that
1.83 times 10 power negative 9.
mole per dm cube, right? So
Yes.
that's the amount of aluminium hydroxide that will dissolve, okay, in a saturated solution. इससे ज़्यादा dissolve नहीं होगी. That's the maximum. And remember, Ksp is for? It's for saturated solutions, okay? Is this clear? ये वाला?
Yes, sir.
अच्छा, mainly 2 questions आएंगे. एक दो और बातें भी पूछेंगे, लेकिन पहले ये कर लेते हैं, ठीक है? We'll just practice more questions. Worksheet क्या है, एक second. अच्छा, इधर ही होगी, एक से 8 week रुपया. So यहाँ पे middle में ना, there would be lots of KSP questions. 1 second, let me just find out. KA, KSP आ गया. So over here, he's saying that AlF3 is not very soluble. So the concentration And remember, you have to be careful. Okay, well, is he talking about a saturated solution or not? Okay, so he's talking about a saturated solution. Otherwise, don't apply KSP. Okay, KSP does not work. He's given us the solubility that okay, this is the amount of AlF3 that's dissolving. Okay, so I know that's if AlF3 dissolves, okay, let's say solid A plus aqueous. So how many ions would it produce? It's going to produce one aluminium ion, and it's going to produce 3 F-1 ions. Okay, aqueous. So what is the expression for KSP? That's going to be aluminium ion concentration times F-1 concentration, and that is going to be cubed. Okay, so that's your expression. And he's saying calculate the numerical value for KSP. So you know how much AlF3 is dissolving. Okay, you know the amount. That's 6.5 times 10 power minus 2. So this is the amount that is dissolving. So how many aluminium ions are produced? That's going to be exactly the same, 6.5 times 10 to the power minus 2. F-1 ions kitne honge? That's going to be multiplied by 3. So that's jo bhi hai, 3 times 6.5 times 10 power minus 2, right? So you found the ions, right? Okay, that's going to be the concentration of the ions. Plug it in the expression. Okay, the expression is aluminium ion concentration, that's 6.5 times 10 power minus 2. Multiply that by F-1 concentration, that's 3 times 6.5 times 10 power minus 2. Up here, wo cube bhi ho raha hai. Okay, so it's getting cubed. So find out what the value is. Yeah. What do you get for KSP?
4.8 times 10 power minus 4.
नहीं बहुत कम value हो गया, I think 4.8 times 10 power minus 4. Can you double check? Can you cube it? So this is minus 6, okay? Oh, minus. नहीं, I don't think that's the right answer. इसके लिए हो सकता है, I'm not sure. लेकिन हाँ, यही है.
Getting the same thing, sir.
नहीं देखिए, ये देखो ना, 10 power minus 2 getting cubed, that's 10 power minus 6 multiplied by 10 power minus 2, that's 10 power minus 8. तो बात जो है ना वो 10 power minus 8 तक चली गई है.
Checking again, sir.
हाँ, तो वो उसको वापस 6.5 और 6.5 तो अच्छा वो क्यूब भी है, हो सकता है आ जाए. ठीक है, just double check this, maybe that's right. हाँ, क्योंकि ये भी क्यूब हो रहा है ना, तो 1000 में चला जाएगा. हाँ ठीक है.
Same thing, sir.
हाँ ठीक है. This is getting cubed as well. This is like 20 getting cubed. तो 20 into 20 into 20 वो बहुत बड़ा नंबर हो जाता है. हाँ ठीक है, तो वो फिर वापस कम हो जाती है. ठीक है. अच्छा, फिर से again he's asking you to figure out the solubility expression. So he gave you Ag2S solid air. It's going to dissolve. It's going to produce 2 Ag plus 1 ions aqueous. And it's going to produce 1 S minus 2 ions aqueous. So इसका expression क्या होगा? That's going to be Ag plus 1 squared. और S minus 2 वो अकेला ही होगा. Power 1, right? And now I think it's the reverse. He's still asking for KSP. So weak question. He gave us कि भी इतना dissolve हो रहा है. That's 1.16 times 10 power minus 17. So that means a very small amount dissolves. So the silver ions will be double the amount. It's going to be 2 times 1.16. and this will be 1.16. Minus 17. Or bus so I'm just going to plug it in the expression. So it's going to be 2 times 1.16. So you have to be very careful with the calculation. 10 power minus 17. So squared, and the other one is just 1.16 times 10 power minus 17, and that's just power 1. Okay. So you're going to get a very, very small value. Kya aa rahi hai?
So 6.24 times 10 power negative 51.
Kitna aa raha hai? 6 point?
6.24 times 10 power negative 51.
Negative 21.
51. 51.
Acha 51 tak chali gayi baat. Acha, so that's extremely low. Agla wala thoda interesting hai. It's kind of moles. They kind of sometimes link it up with moles. So calculate the minimum volume of water needed to dissolve 1 gram of acha, now you know the solubility. Acha, so wo moles ka agla. You know the solubility, right? It's solubility kitni hai Ag2S ki? It's, I mean, the concentration of Ag2S is given over here. Okay, this is the amount that dissolves, 1.16 times 10 to the power minus 17. ठीक है. The question में कह रहा है, what is the amount of water that needs to be dissolved? I mean, to get this concentration, right? So you're trying to figure out what is the amount of water, what is the volume of the solution that 1 gram of Ag2S. तो आप moles निकाल लो. Moles क्या होंगे? Moles would be, you got 1 gram divided by Ag2S MR, which is I don't know what that is. Silver कितना होता है? So I think it's 107.9. Sulfur is 32.1. अच्छा, into 2 होगा. अच्छा, sulfur is 32.1. तो कितने moles आए? I'm just trying to calculate the moles of this thing.
4 times 10 power minus 3.
Exactly 3 significant figures, yeah. 4 point kuch hai.
4.033.
So 0.3 कर लेते हैं times 10 per minus कितना?
3.
So you're getting 4.03 times 10 per minus 3 moles. ठीक है, this is the amount that you're getting. So concentration क्या होती है? Concentration is moles over volume, right? So you know the concentration, you know the moles that you're adding, so you can find the volume of the solution. So concentration is 1.16 times 10 per minus 17. Moles पता लग गए. 1 gram में how many moles? That's 4.03 times 10 to the power minus 3. So पीछे the only thing that's missing is volume, right? It will come out to be in dm cube. So calculate करो what is the volume that you're getting.
So 3.47 times 10 power 14.
Times 10 power minus कितना?
No, not minus, just 14.
14?
14, sir.
अच्छा, ये तो कुछ ज्यादा वॉल्यूम नहीं आ गया. ज्यादा ही होगा वैसे, क्योंकि Ag2S is so insoluble. हाँ, obviously मतलब आपके moles इतने ज्यादा ना, क्योंकि DMQ में there's a very tiny amount of moles that actually dissolve in it, right? So you would need a lot of DMQs to dissolve 1 gram. हाँ ठीक है, that makes sense. A lot of water would be needed क्योंकि it's so insoluble. ठीक है, चलो ठीक है, ये clear है?
Yes, sir.
तो बस ठीक है. करते हैं नेक्स्ट टाइम करते हैं, इसका बस थोड़ा सा रह गया, ठीक है, अदरवाइज केस भी इज डन एज वेल। चलिए ठीक है, फिर अगली क्लास में कंटिन्यू करते हैं।
Thank you, sir.
ओके, अल्लाह हाफिज।